is important to you. Record this from now. And then regular time cost, $40 per item. This one is tire company, so $40 per tire. Using overtime, $50. And then subcontracting, using subcontracting cost is $70. And then carrying cost, $2 per tire per month. So now beginning inventory, if produce more and then carry over to next month, then $2 per tire. Then we can use Excel solver to solve this problem. Looks very complicated, right? Last time you did an assignment method using solver, right? That one was just simple, right? Similar, but this one is more complicated. So last time we used an assignment method of linear programming, but this time we use transportation method, similar one. So assignment method, assign a one-to-one, right? Remember? But this one, same number of destination, same number of supplier match, and then their amount match. So a little bit more complicated, but I think you can do it. So let's do it. Okay, there is the example file, Excel file is on module. So click this one and then open this one. I will show you one by one. That we do love with your feedback. Looks like this. A little bit small. So from the example, this one. So we need kind of the capacity table and a cost table. So I made spread table like this. First, we need cost table, here information. So from this chart here, regular time, how much? $40. So type 40. I made this one, this cell already in a dollar sign currency cell. And then overtime, $50. Subcontract, 70. So you can do it together, better understand. And then carrying cost is $2. Like this. So cost table. And then next one is like a cost table 2. So beginning inventory, if there is no beginning inventory here, then cost will be 0 because it's already there. So it will be 0 cost. Oops, not that one. This cell. Beginning inventory. So now cost is 0. And then next, if produce here and then carry over, then $2 per item, right? That is here. So this cell will be equals earlier one plus sign and then this carrying cost. And then we will use that carrying cost again and again. So make it absolute value. Type F4 function key, F4 function key, then it changes like a $sign, then cell C $8. So $sign, that is an absolute value. But by typing F4 function key, enter $2. And then this one, carry over, then copy. You know how to do it, right? So make it this cursor, little plus sign, right, left, right, lower side, then dragging and copy it. $2, $4. And the regular time, 40, overtime 50, subcontract 70, right? So initial, we need, you can just copy this 3 cells and then paste. The number is okay. Then here, what do you think? The same. Copy $40, 42, 50, 52, and so on. Copy. Because we did here, earlier one plus $2. Earlier one plus $2. Then here, again, paste. And then copy again. And this one, Control C, Control V. So this means same month produce, use the same month. Produce March, use April, carryover, and so on. So March, so on. Then $2 increase, $1 increase again, $2 increase, and so on. cost like this. And then here, in this box, that means produce produce in April, supply from, produce in April, use in March. Possible or not possible? Produce future, use current. Not possible. So not to assign that cell, this case, because this one is cost problem. So make it big number. So 9,9999 like that. Then this program will not assign these cells. So just copy, copy, copy. Then here, like this, demand and supply different. Like in the assignment method, match one by one. This one, transportation method, match amount. But the demand and then capacity unmatched. That case, we need dummy column or dummy supply or dummy demand. This case, capacity is more than demand. That case, we need dummy demand. So unused capacity. So unused capacity to match the amount, because unused capacity cost is 0. So this unused capacity cost is 0. So here, not feasible, big amount, unused, 0 cost. So this is the cost table. And then here, like a solution table. How many produce use what method? So here, after run this program, then this program give us answer here. And capacity, demand and then capacity. So from this table, we need this cell and this cell here first. Now, beginning inventory is, it says 100, so type 100. And then regular time, here 700, and then 50, 150. So 700 supply, that is capacity, and then 50, then 150, then April 700, $50, 150, $700, $50, 50, 130. Okay. And then here, demand 800, 1,750. So type 800, 1,000, then 750. Then this unused capacity, here total capacity, including beginning inventory. So total this one minus this one, right? Unused. So that will be equals type equals. So sum of all capacity. So sum type sum all of them plus the minus the sum of demand plus, so 230. It will be 230. Okay, now we need this cell. So this row, sum of row is this one, sum of row is this one. So equals sum of here, enter. Then you can do it one by one, but we cannot copy by dragging down. Then here equals sum of all, then copy, drag to the right side. So this table is now complete, and then we need cost. So last time, assignment method, when you did, this part is how many and then cost, plus how many cost, how many cost. So this is how many, and then here, cost. So using sum product equals sum product. So function sum product and area, cost area, comma, that is this area and that another area, this area, enter. Now it's 0. So we are ready to run the solver. Then we can go solver. Do I have? The data. Oops, I don't have. Okay. Option. In. So solver. In. Okay. Okay. I need a solver. Yeah. Click solver. And this objectives cell is this one. So select this one. Then changing variable here. It's the same as the last time the assignment method. So changing a variable here. Then we need a constraint. So it is like this one equals this one, this one equals this one, this one equals this one, and so on. So add. You can do it one by one, but we can do it all of them. So this area equals this area. Then we need another, so add this area equals area. Okay. So we need an objective cell, changing cells, and then constraints. This one, this one, this one, this one, and then here, here, here. And this one is a minimize problem. Then using simplex, solve. And look at the answer. Looks okay. So okay. So this aggregate planning for March, demand is 800. So using beginning inventory and then using regular time produce 700. So match 800 demand. And then for the April demand 1000 produce using overtime in March 50 and subcontract 50, and then in April regular time 700, overtime 50, and subcontract 150 to match 1000 April demand. And then May, use just May production. Use May production, and then unused capacity is 1,100 March, then 130 May subcontract. So unused is 230. Then this table I made, you don't have to touch. So I made this one just to show you how many production. So here 100 beginning, monthly 800, produce 700, and then 50-50. So total March production is 800. So demand is 800. So 100 total is 900. 100 carry over to April. Then produce 900. So match 1,000. Then there is no inventory carryover. But produce May and then use May. Looks complicated, but it's kind of fun. Any question about this? Okay, good. And then you have an assignment from this chapter. this one. So this one assignment question, and then I made a pre-table, a tablet, and then here instruction how to do it like last time. So try. You know, this one, if this class is a management science class, then I ask you make that table. But this one is operations management, so just to show you how it works. So maybe later, if you need that kind of technique, then you may take management science, or in business and analytic courses, they call prescriptive analysis. So use solver optimization. So one of the technique is this transportation method, optimization method. So just try. So I gave you this instruction. I made instruction like this. So cell by cell, I give you instruction where what number. Okay, so just follow this instruction, then you can do it. Okay. So that's all for chapter 13, and then chapter 14. You don't need a break. Just keep going. Maybe about 30, 35 minutes more. Okay. Okay, next one is chapter 14, material requirement planning. Simply we call it MRP system. Nowadays, we use many companies use ERP system, enterprise resource planning. Many people say ERP system from this the advanced developed from this MRP system. Many cases we call MRP, MRP2, and then ERP system. I don't know if you know about that. You know, MRP, then MRP2, then ERP, enterprise resource planning. So what's different? So this one, MRP system is a single database, used in a single database, and then used by one department, maybe two, not many. So use one own database. And then MRP2 system, the same, use one database data, then more departments share database, then a program. So that is MRP2. So data here, 1 or 2. So from MRP2, we call that integrated system. So more multiple departments share database and program. The enterprise ERP or department in a company use the same program and database. So that is ERP system. So we say from MRP system to ERP system, advanced and developed. So this is an MRP system. The MRP system is mean for determining the number of parts, components, and materials needed to produce a product. So planning tool, planning system. MRP provides time scheduling information specifying when each of the material parts and components should be ordered and produced. So by planning when, how many, which one, and so on. So determine the date when orders for those materials should be released based on lead time. Lead time is time between order and receive. So if we need 5 days later and then lead time is like 3 days, then at least we order in 2 days to match that kind of due date. And then using this one, we can get the right materials to the right place at the right time. Improve customer service, minimize inventory, maximize production efficiency, and so on. So program, the same, make it better, cheaper, faster. And then based on dependent demand, part demand is dependent demand. Final product demand is independent demand. So MRP system based on parts, not the final product. And then MRP system is software, computer software, like an MRP2 and component of ERP. So this day, many companies still use the MRP system as part of or component of ERP system. And MRP system structure, to run MRP system, basically 3 required files. There are 3 required files. Bill of material, MPS, inventory record file, based on 3 required files. Run and then produce primary order schedule, primary report, when, how many, which, and so on. Then if there is a change, like a demand change, then this program produce secondary report such as exceptional report. First required file to run MRP system, master production schedule, MPS. This one show finished product, how many product finished product need. This one from aggregate planning, then by disaggregate. So this one is MPS. Aggregate planning, first term or month, 900, second month, 950. So disaggregate model 327 need 200 first week, 400 model. Other models need a different number like this. And then bill of material. This one shows structure of product. So BOM, simply we can call this one BOM, show final product structure, component and part structure like this. And then when we develop this bill of material, use low-level coding method. That is, before using this method, maybe the same part in a different tier or level, same part R here and R here. So that case, maybe it can cause of miscount. Bring all the same parts on the same tier or level. So n part here, n part here are so the same part on the same level. So that is low-level coding method. And propose making easy to compute the total number of each part needed. So that is low-level coding method. And then inventory code file, the last required file like this. So this one, from this one, we can see inventory on hand, and then how many are already ordered, and then when received, and so on. So based on three required file, and run. And then ordering policy, or lot for lot ordering system and fixed lot ordering system. Lot for lot ordering system, when we order, the order size is requirement, that requirement. Like if we need 500, but we have 100 on hand, then 400 is that requirement. So order that requirement. So that is lot for lot ordering system. And then fixed order lot system using EOQ model, economic order quantity model. Then based on this model, fix that order size and then use that order size again and again. And then maybe we can use list total cost. So if we order quantity is just 1 week required, 50. And then order 2 weeks required, and so on. Then carrying cost and ordering cost. From this idea, increase order size, then ordering cost, and then inventory cost. The order cost decrease, but the carrying cost increase. So this one, when ordering cost and carrying cost meet on this point, the list total cost or the unit cost. So find this order quantity. So by subtracting this order cost minus carry cost, then this difference smaller, and 0, and then increase and so on. So difference is 47. 47 minus 0. Then 47 minus 30, 43. So 44. Then 37. And then 28. And this one is how much? 9? 9. And increase again. So if we can find this exact 0 difference, but maybe here and then here. So among them, the smallest is this one. So order 335 based on list total cost. And this 335 is optimal order quantity. The next one, if we use list unit cost and order 50, and then cost, carrying cost plus order cost. So order quantity divide again. Cost divided by order quantity, that unit cost. Cost divided by unit quantity, order quantity, this unit cost. Among them, smallest. Then, if we use this rule, then 410 is the optimal order quantity. So, using those methods, then we can order. Example 2. Boring, right? Blah, 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 blah. Yeah, me too. So let's finish as fast as possible. So maybe 10 minutes more. Good. You know, because I wear 2 masks, so it's okay to breathe, but maybe it's, you know, even though it's I feel okay, but it's uncomfortable, right? So longer than 1 hour, then tired. And then also one more problem is this band squeeze my ear. So 1 hour, longer than 1 hour, tired. And then also boring. How's there online? Very quiet. That means that they just turn up the camera and then somewhere. All day.
Everything is fine, Dr. Kim.
Thank you, Isa. You know, when I teach online only, then all students come in and then they turn up the whole camera. Even if I finish, they are still there. So they turn up the camera and then maybe somewhere. So I tested then certain students 20 minutes later up. Okay. You know, if this class is a regular time class, then I try to make more fun. But this time, just to try to finish it fast. Okay. Example, first required file, master production schedule, MPS. This one from aggregate planning. So product A need 800 in fifths and tenths a week. And then bill of material structure A, type A product, final product need 1B and 3C. Inventory equity file on hand A70, C1000, B there is no inventory on hand. Lead time 132. If there is no safety stock and then already ordered 50 A final product, they will come in week 2 and week 7. So if we run MRP system, then it works like this. But I cannot show you because the MRP system is like a licensed program software. So and then usually a big one, so I couldn't get that program. So just to show you how it works. Okay, based on MPS, final product A need 800 in fifth and tenths. So just copy like this. And based on inventory code file 70 and 1000, schedule 50, 50, week 2, week 7. And then 70 on hand. So starting inventory is 70. So available project available balance 70. Initial balance 70, and then week 2 120 because we received 50, and then the same here 800 need, but inventory is only 120, so need 680 more. So order and receive 680 because this one used lot for lot order system. So that requirement is 680. So receive that many, to receive that many 1 week earlier. 1 week earlier order because lead time is 1 week. And then based on this bill of material, final product A need 1B and 3C. So to produce 680 final product, we need 680B and then 2040C because now times 3, the same time. And then there is no on hand, so available balance is 0, 0, 0, 0 up to this point. So net requirement is 680. Receive that many, to receive that many on time because lead time is 3 weeks, order 3 weeks earlier. Then part C, 1000 on hand. Up to this point, 2040 need, but 1000 available. So net requirement 1040. Receive that many on time, 2 on time, 2 weeks earlier, and so on. So work like this. If we use this company use lot for lot, then looks like this. And then if this company use fixed lot, for A, use lot for lot, and then fixed lot for part B and C. Up to this point, it's the same. Fixed lot, if 900 is economic order quantity for part B, and 2000 is for C. Then even that requirement is 680 because 900 is order economic order quantity, so order 900. Then here 2000, even they need 1040 net requirement. So after that, 600 need more, 680 need more, but order 900, so 900 minus 680 carry over is 220. So up to that point, and then 530 need, but 900 is fixed, so order them many, and then carry over and many. The same here. 1040 need more, but order 2000. So 2000 minus 1040, 160 carry over, and so on. The same. 1290 need more, but order 2000. 2000 minus 1290, 710 carry over. So compare two method, ordering method. Lot for lot, if this company use lot for lot ordering system, then inventory is 0, minimize inventory, but every time change order size. But if this company use fixed lot, even there is no inventory carryover, maybe inventory cost high, but they don't need decide order size every time. Just one time and then use that one again and again. So we cannot say method is better. If it is like a make to order system, then maybe use lot for lot. Order stock system, then use maybe fixed order lot size system. Okay. I think that's all for this. Okay, okay, that's all. See you next Wednesday. Wednesday, right? Wednesday, online only. Okay, hopefully everybody safe, and then see you next week all in health. Okay. Okay, let's start outside. Okay, bye.
Bye, Dr. Kim.
Thank you.
Bye, Dr. Kim. Thank you.
Thank you.
Thank you.